Today's lesson is about the volume. We can use definite integral to find the volume of a solid that is obtained by revolving an area region about a horizontal or vertical line that does not pass through the area. So there are four formulas that we advise you to memorize. The first one is when this area let's say S is revolved about the x-axis. So the revolution generates such like solid. So the formula in this case would be volume equals pi integral from a to b y squared dx. The second formula serves when you revolve an area about the y-axis. So this is y equals f of x, and you are going to revolve it about the y-axis. So we expect such like solid, like a bowl. So the formula in this case would be v equals pi integral from c to d x squared dy. The next one is about the area between two functions about the x-axis. So suppose that this is f of x and this is g of x. Let me say y1 and y2. So if you revolve the area between these two curves about the x-axis, we are going to use this formula. Volume is pi integral from a to b. Farther squared, in this case farther is y2 from the x-axis, minus y1 squared dx. And if you are going to revolve the area between two functions about the y-axis, we are going to use this formula. dy. So x2 is the farther function from the y-axis, and x1 is the one that is closer to the y-axis. Let's have some examples. So consider y equals x squared from 0 to 1. First, I want to revolve it about the x-axis. So v about the x-axis would be pi integral from 0 to 1 y squared dx. Since y equals x squared would be x4 dx. Integral of x4 is 1/5 x5 from 0 to 1. So it's going to be pi over 5. Now I'm going to use the same function and I want to rotate the red area about the y-axis and to see what the volume is. So volume equals pi integral from 0 to 1 x squared dy. Having dy in your integral shows that you need to replace all x's with y's, so no more x in your equation. Since you have y equals x squared, we are going to isolate x, so x becomes the square root of y. Therefore, we are going to replace x squared actually with y. I shouldn't have like isolate x because we are looking for x squared, and x squared is directly equals y. So it becomes pi over 2y2 from 0 to 1, which becomes pi over 2. Simple. The next one, the next example, this is y equals x squared, and the second function is y equals square root of x. So the area between these two curves is revolved about the x-axis, and I am going to find the volume. So pi integral from, I think it's obvious that the intersection point is 1. So 0 to 1. So the function which is farther from the x-axis, how do I know that? I can draw a vertical line here. So if you look at these two intersection points with the vertical line, so if you look at the distance of them from the x-axis, you will see that root x is farther away from the x-axis. Therefore, it's going to be root x squared minus x squared squared dx. So x minus x4 dx. So integral of x is 1/2 x squared from 0 to 1, and integral of x4 is 1/5 x5 from 0 to 1. So it's going to be pi 1/2 minus 1/5. So it's going to be 3 pi over 10 by applying common denominator. Now consider y equals x cubed. And y equals square root of x again. So the area is the black area that is marked here. We are going to revolve this about the y-axis, and we are going to get the volume of generated solid. So the formula, as you know, is pi integral from 0 to 1, which is the intersection point. I leave it to you to consider how the intersection is 1. 0 to 1 x2 squared minus x1 squared dy. So we need to isolate x's in terms of y. So which x is farther away from the y-axis? You can draw a horizontal line. So this is this big, its distance from the y-axis, and this one is this big. Obviously, x cubed is farther away from the y-axis, but x becomes cube root of y, and in here, if you isolate x, x becomes y squared. Therefore, v becomes pi integral from 0 to 1 farther, which is x cubed here, squared, which becomes cube root of y squared, minus y4 dy. So this one can be written as y to the power of 2/3 minus y4 dy integral of y to the power of 2/3 is 2/3 plus 1 is 5/3, and this one would be 1/5 y5 from 0 to 1. So 3/5 minus 1/5, which is 2 pi over 5.